Now let us learn something more about green sand molding. Green sand molding is the process which is widely used. In fact, it has been in practice even during BC. Our ancestors, our forefathers have been using green sand molding, and it is in practice even today. So let us learn something more about this green sand molding. As I already told, the term green denotes the presence of moisture in the molding sand. And we have already seen the composition of the green sand is silica sand in most of the times, binder and moisture. And what are the advantages of the green sand molding? One is, most metals can be cast by this method. Whatever be the composition of the pouring metal, we can cast the component. And pattern cost is very less. Most of the times we use a wooden pattern, so the cost of the pattern is very less. And coming to the size of the casting, any big size casting can be made. Similarly, even a small size casting can be made. So there is a flexibility in size. There are other casting processes where there is no flexibility of size. Only small castings we can make, bigger castings we cannot make. But by using green sand molding, we can make any size component. So these are the important advantages. And also another, the molding material is not costly. What is the molding material? Silica sand and clay and moisture. These are not so expensive. These are abundantly available. So the process is cheap. And this has got some disadvantages also, green sand molding. What are the disadvantages? There will be poor surface finish. In most of the cases, the pattern used is the wood. The surface texture of wood is not very fine. The surface finish of the pattern, wooden pattern, is not very fine. Then with such a wooden pattern, when we make a pattern, what will be the surface finish of the surface of the cavity? It will be irregular, it will be rough. So to get a fine surface finish, we have to do machining operation. For that we have to spend more time, we have to spend more labor, we have to spend more money. So this increases the cost, this increases the time. So this is one of the major drawback of the green sand molding. Another one, we have already seen the ingredients of the molding sand. One is the silica sand, another one clay, and another one the moisture. If these ingredients are not controlled properly, then that arises problem. If the moisture is too much, it will lead to porosity. There will be blowholes and there will be defects in the casting. If the moisture is not sufficient, if the moisture is less, then the strength of the mold will not be sufficient. It may fail at any time. During solidification, the sand may fall into the cavity. Once the sand falls into the cavity, over that sand molten metal falls. That leads to rejection of the casting. So the ingredients of the molding sand, that is the base sand, clay and the moisture, they should be controlled carefully. And what happens if the clay is not controlled properly? If the clay is not sufficient, the binding capacity of the molding is not sufficient, it won't be good. At any time it may fail. On the other hand, if the clay is too much, the porosity will come down. After pouring of the molten metal, the molten metal comes in contact with the moisture. That time vapor will be generated. This vapor has to escape. the excess clay present in the mold, it prevents the escape of the hot gases. Ultimately, the hot gases will be taking a room inside the mold cavity. This leads to defect. Another one, unclean environment. All the time the people in the molding shop, they will be working with the sand, clay, mixing the sand, mixing the clay, mixing the moisture. They will be mixing. Clay will be raising. And the environment becomes unclean. So this leads to unclean environment. So this is another drawback of the green sand molding. Let us see the sand mold making procedure. How to make the sand mold? As the green sand molding is popularly used, it is very popular. It has been in practice right from the beginning. We need to learn what are the steps involved in making a mold, in making a casting with green sand molding. Let us take a case study where, so we are making a cast iron wheel of this shape. Here the cross section is shown, it is cut, but we are going to make the complete wheel. What are the steps involved? First of all, we have to use a pattern of this shape, and the pattern will be split pattern. Next, first one is place the pattern on the molding board. So this is the molding board. This lower one is the molding board and is the one half of the pattern. One half of the pattern. So initially we have to place this pattern over the molding board. Second one, place the drag on the board. So this is the drag. Drag means the lower molding flask. So this lower molding flask, which is known as drag, is to be kept over the molding board. Next, sprinkle dry parting sand over the board. So here over the board and also over the pattern, dry parting sand we have to sprinkle. What is this dry parting sand? The dry parting sand is fresh silica sand. So this will be free from clay. This will be free from any other dirt particles and moisture. And why we have to sprinkle this dry parting sand? Because we are going to place the molding sand over the molding board and the pattern. And after molding is over, we have to withdraw the pattern. That time the pattern should be withdrawn easily. Since the molding sand contains moisture, it easily sticks onto the surface of the pattern. So that we have to prevent. For that sake, we take this dry parting sand and we will sprinkle over the pattern and over the molding board before putting the molding sand, so that it makes a thin layer, dry layer between the molding sand and the surface of the pattern and the surface of the board, so that after the molding is over, this pattern can be withdrawn without any problem, without sticking. Next one, compact the drag with molding sand. So this is the drag. Next, after sprinkling the dry parting sand, then we will place the molding sand here and we will compact. We use rammers and we compact them. Of course, there are machines which are meant for compacting. Compacting is done manually and also by machines. Next one, when we do this compacting, there is a chance there will be excess of sand over the molding box. So this is the drag box. It is always difficult to exactly compact the sand up to this level. There is it happens the molding sand may be more than this line. So this excess sand is to be removed by a strike of bar. There will be some rods which are very straight, very sharp. Taking those rods, we have to strike the excess sand. Next one, make vent holes in the drag. So now we have compacted the sand. Now we have to make some vent holes here. Why these vent holes? Because soon we are going to mold the other half, and after that we will be withdrawing the pattern. Then we pour the molten metal. When more molten metal comes in touch with the moisture, vapor will be generating. That vapor has to escape. But yes, we have already discussed that the molding sand possesses one important property, that is the permeability. So because of this permeability, it allows the hot gases to pass through it. But sometimes we might do it wrong. We might have mixed more clay. So it may so happen that the permeability of a particular sand may be a little poor. Permeability may not be so good. At such times, we have to be safe. We have to be on safe side. For that purpose, we have to make vent holes. These vent holes will be, the diameter of these vent holes will be maybe 2 mm, 3 mm or 4 mm generally. So there will be some vent pins, long pins, thin pins. Using these vent pins, we make vent holes. We insert it in the mold and you take it out. Then a small hole is created of diameter maybe 3 mm or 2 mm. These holes will help the hot gases and vapor to escape from the mold. So that is the purpose of the vent holes, making the vent holes. Now after making the vent holes, roll over the drag upside down. Means now here the pattern is at the bottom position. You make it upside down so that the pattern comes up and this upper portion comes down. With that, the molding of the drag box is complete. Now let us see how to compact the sand in the cope box. Place the cope of the pattern over the drag pattern. So this is the pattern is split into two parts. This is one half, this is another half. This half is known as the drag half of the pattern. This half is known as the cope half of the pattern. So after the molding of the drag box is complete, we have to place the cope half of the pattern over the drag half of the pattern. And while placing the cope of the pattern, care must be taken so that they will be properly aligned. For that, there will be some pins will be there. Alignment pins will be there between this surface, and this upper half will have some pin, and if we align them properly, there will be a small hole here. That pin has to rest in the hole. When the pin rests in the hole, then the drag off and the cope off of the patterns are properly aligned. Next one, keep the cope flask over the drag. Next, this one is the cope. Cope means the upper molding flask. So this upper molding flask has to be kept over the drag. Again, they should be properly aligned. To ensure proper alignment, there will be dovetail pins will be there. Here we can see dovetail pins, and here we can see dovetail pins. Means this pin has to pass through this hole. There is a hole in this part. So by using these dovetail pins, we will ensure that the cope and drag are properly aligned. Next one, sprinkle the dry parting sand over the drag and the pattern. Here, over the pattern and over this line on the parting line, we have to sprinkle dry parting sand. Why we have to sprinkle this dry parting sand? Because again we are going to place the molding sand, and we are going to ram the molding sand over this pattern, and after molding is over, we have to withdraw the pattern. That time there should not be sticking between the molding sand and the pattern. The pattern should be withdrawn easily, and the sand of the cope box should not be sticking to the molding sand of the drag box. For that purpose, we are sprinkling dry parting sand starting from here and here, 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 here. We will be sprinkling the dry parting sand. Next one, place the sprue pin for making the sprue passes. Yes, we have to pour the molten metal. For pouring the molten metal, the passes is sprue. The passes through which we pour the molten metal is known as the sprue. So here we have to create a passes for pouring the molten metal. So for that purpose, we place a sprue pin here. It is made up of wood generally in most of the cases, right? Again, that has to be withdrawn. Next one, place the riser pin in an appropriate place. Riser is required. What is this riser? As I have already described in the previous class, it has got certain functions. It gives us an indication that the mould cavity is full with the molten metal. It also helps us so that the hot gases generated inside the mould will be escaping through this hole. Finally, it has got an important function. What is that? When the molten metal in the cavity is undergoing shrinkage, that time the molten metal in the riser will be in liquid state. This will be compensating the shrinkage. If the casting is about to become small, this helps the wanted material, the wanted metal. So that is the important function of the riser, and we have to create a space so that metal will be poured in the riser also. So here is the riser pin. So we have to place a riser pin for this purpose. That is also made up of wood, that has to be withdrawn after the molding is over. Next one, and we also have to create the gating system, the runner and the ingates. For that also there will be gating system made up of wood that we have to place near the sprue, between the sprue and the casting we have to place. Next one, apply facing sand. Before that, compact the cope with molding sand. After placing the sprue pin, after placing the riser pin, then we have to put the molding sand and we have to compact it. And after compaction is over, there will be excess of sand will be there. That excess of sand has to be removed. There will be striking rod will be there, sharp rod. With that we strike it so that the excess sand will be removed. Next one. Next we have to make the vent holes. Yes, sometimes the permeability of the molding sand may be poor. Permeability is the ability of the molding sand to allow the hot gases to pass through it. Yes, if the permeability of the molding sand is very good, no problem. Sometimes it can happen that the permeability of the molding sand will be poor. At such times we should be on safe side. So we create the vent holes. As we have created the vent holes in the case of the drag box, in the similar way we have to create vent holes for this cope box also. Next one, withdraw the sprue pin and riser pin. Here we have inserted one sprue pin and here we have inserted riser pin. These we have to withdraw. And also we have inserted gating system for runners and ingates. Those also we have to remove. We have to withdraw. Next one, scoop the pouring basin. So this is the pouring basin. When we have only created the passes for this sprue, it will be like this. The entrance won't be so big. So when the entrance is very small, it is difficult to pour the molten metal. So we enlarge the entrance of the sprue. We call it as sprue basin. So this we have to create. We have to cut the sprue basin. Next one, withdraw the pattern from the cope and drag. We will withdraw the pattern, this pattern, and from the drag and also from the cope. Apply facing sand all over the molding cavity. Yes, this is the molding cavity, and the surface of the cavity is not smooth. It is rough because we have used wooden pattern, because we have used molding sand, the surface is not smooth. So there will be facing sand, fine sand will be there. That sand will be applying on the surface so that the surface of the cavity will be improved. Next one, the mold is now assembled. This is the assembled mold. This is the drag box, this is the cope box, and this is the mold cavity. This is the pouring basin, and this is the sprue, the passage through which we pour the molten metal. And here is the runner and ingates that are not shown here, and this is the riser. And now it is ready for pouring. Yes, the mold is now ready for pouring. So we have seen the steps involved in making a mold for green sand molding.